Hope I'm audible to all.
Yes.
Okay. So I can see still people are joining. In the meantime, you guys have any question based on yesterday's session? Do you guys have any question? Please let me know.
Yes, I am having. Uh, I have tried that GitHub webhook and I have made some changes in the HTML folder there. After that, when I came in Jenkins module, so uh, it was showing me that I have clicked in GitHub hook log. Then it is showing polling has not run yet. Message error message. It is not showing me the trigger.
No, you can just enable the checkbox. Okay,
Yes,
GitHub
I have
webhook
enabled.
checkbox
Huh.
and save the job. That's it. That's all you can do there.
It will not show me some trigger or something like that.
No, it won't show any trigger and all.
Okay,
So
okay.
just enable the checkbox, save that job, and then go to your source code repository. And if you configured your webhook URL properly with your Jenkins URL along with the port number and the tag GitHub-webhook tag, if you if you managed it and if it is active, it will trigger your pipeline project whenever you make any changes there. That's
Okay.
how it works.
Yes, yes. I have done all the things. So I thought some message like that console out or
Nothing, nothing,
something.
nothing like that.
Okay. Okay.
So any other question you guys have?
One more thing. If I want to run slave one and slave two node, and I want to have all the what to say that SEM checkout, build, deploy in slave one also and in slave two also. So I will run the syntax first for slave one. After that, same only I will change level slave two and do same thing for the slave two, like that. Or
What you want to do with both these slave nodes?
pardon me.
What are you going to do there, like with both the slave
I
nodes?
want to do this SCM checkout, build and deploy in Tomcat.
Okay.
Same time, both the slave nodes. Is it possible?
See, your slave node is meant only for your build activity, right?
Yes.
So you can able to use your, another second slave node, create a node configuration, and then add it to your agent as a label. It should be fine.
So that level I will add after slave node syntax. After that, that syntax I will add, right?
Yeah.
Okay.
And another important thing, the slave node details, you can able to add it at the stage level also. Within the stage also you can able to do. So if you're talking about your continuous integration, continuous delivery deployment process, instead of declaring the node details at the pipeline level, within this stage, you can use the same agent label equal to this agent name. Similarly, you can add another stage and you can able to have it like this. You can able to have more than one stages with multiple slaves. That's also possible. It means if you define your agent name at the pipeline level, it is applicable to all the stages. But if you want to run any specific step in one particular agent, you can use that agent name in a specific step also. It's possible. So let me get into the next topic here. It's clear, right?
Yes.
Okay, so we are on day 28th of February. We just have 28, right? Super. So 21. Okay, so in today's session, we'll talk about the email notifications first. Jenkins pipeline. So we'll see this and then we'll start with the next module called Docker module. Correct. Hope all are there. I can see most of them are yet to join. Like any problem? It's okay, no worries. So uh, okay. Okay, it's okay then. We'll continue. So before that, you guys, are we good to proceed or any questions to me? Good, right?
Hello, sir. Hello, sir.
Yeah.
Uh, I have doubt. So, suppose I have like one master node and I have two slave nodes. Just assume it like that. And I want to execute two two tasks in a two different slave nodes. Is it possible?
Yeah, you can. That's what I told you, right? You can give the stage slave name in this step level or a stage level. For example, this is your pipeline project, right?
Yeah.
So what we did here, we use as agent label at the pipeline level. So when you define it at the pipeline level, this slave is applicable to all the stages. That means the SCM checkout will happen in the slave one.
Okay.
Application build will happen in slave one. If you want to do it in any specific slave, instead of maintaining it here, you can use it here also. Within the stage, you can give the slave name like this.
Okay, sir.
Correct.
Yes.
So this step alone will get executed in slave two. Like that, you can able to plan your agent. Right?
Yes, sir.
Fine. So, all right. So when we talk about the DevOps workflow, if you can see our CI/CD process, like as part of your DevOps best practices, like here during your continuous development stage, using DevOps approach, we are going to automate the application build, perform the automated unit testing, and then the code promotion. So we have done all these things through DevOps approach. So developer, they can simply commit the changes. And once the changes are ready in the source code repository, through our pipeline, we can able to achieve all those things. So now you can able to relate, right, what we have discussed on very first day of our DevOps and what we achieved today. So as part of this automation, at each and every level of your CSD pipeline, you have to send some email notifications to the concerned team, right? So let's say for an example, in this script, assume that we are performing the SCM checkout, application build, and then we are deployed to QA server. So once the application SCM checkout is completed, if it is successfully completed, we can directly go on move on to this particular stage to pick up the code and perform Maven build. What if this SCM checkout fails? Due to some reason, the repository is not present, or if it is not accessible, due to some reason that SCM checkout stage gets failed. So what you can do there? Hmm? The pipeline project will be failing, right? So in that case, you can simply route your request or schedule to your next stage, or you can able to send the email notification. So when you send the email notification, the concerned team will be notified through Jenkins pipeline. Similarly, assume that we are performing application build, and as part of that application build, there is some issue happens. There are unit testing cases are failing, or build itself not successful. There is some compilation error in the program. So if that is the case, the artifacts will not get created successfully. So immediately you can send that notification, email notification to the development team. And what about the last stage? Whether the deployment is successful or unsuccessful, you have to send the notification. If it is successful, we can notify the development team and the testing team. If it is failure, we can inform the development team. Correct? So to achieve all these things, first thing, we have to set up the email server. That means you should have a valid account. So here we'll be using Gmail for your mail configuration, or you can consider Gmail server as a mail server for Jenkins. And this account should be enabled with the access token, or we call it as application token. Correct. So this acts as a credential to configure in Jenkins. All right. And then you can log into Jenkins server, and under manage Jenkins, you can find an option called email notification. And there you can able to add the email server configuration. That's it. And test the email configurations. Easy. So these are the steps involved. Hope you all have Gmail account. And in order to log into your account, what we use actually, we'll be using our email ID and the password. We usually use the email ID and the password. But if you want to access the same email server through any external APIs or any other services, we cannot use a password. We use the token. It is same as like how you used your GitHub access token to push the changes from your local machine to remote server. Similarly, you have to create one access token in your Gmail account. So I hope you all have your account enabled with the MFA, right? Multi-factor authentication.
No,
Yesterday I was expecting, right? Like, did you get a chance to do that or not?
no, I haven't done that yet. We'll do it for sure.
No, we have done.
It's okay. So I'll just give you the steps, okay? I cannot log in and show all those details because it is a personal account. Even I don't want you people also to share your screen. Okay, if you have a dummy Gmail account, that's fine. But if it is your actual Gmail account which you're using for your personal access, don't share it here. But I'll be giving you the steps that you can follow by yourself. It's very simple. Okay. So in order to set up your email, first you need to set up the email server in Jenkins configuration. But before that, you should have a valid email account. Got it. So I'll talk about how to configure it in your Jenkins in some time. But before that, you have to have your Gmail account. So just log into Gmail account first. And once you log in, you can go to your account settings page, right? From your account. On top right, you can see your user icon, right? If you click on that user icon, you can see there is an option called account settings. From that account settings page, at the left side panel, you can see there is something called security tab. If you click on the security tab, and you'll be getting a page where you can able to see the multi-factor or two-way authentication. You have to enable this. So in order to enable this two-way authentication, you have to enter your mobile number. You'll be getting that OTP, verification code, everything. Once your mobile number is verified, then only you can able to create app password. So once your mobile number is verified successfully, and if this process completes, on the same page, the same security page, in the search bar, you can search for app password. You'll be getting an option to create app password. Just click on create. It'll ask the name of that password which you want to create, like just a name, like how you assign your token name, right? In GitHub, like that, you can give a name and ask for what purpose you want to create, for which application you want to create. Just choose Windows as a drop down and choose as email, these two options. Once you enter this, you'll be getting a 16 bytes of application passcode. So this is what we need to provide during your configuration. Any question on this? Any question here?
No.
No, sir.
Let me start this instance. I think it's already started. Oh, okay. Just a second while it is running. Okay, so let me connect to this machine. In the meantime, if you want, you can try to your Gmail account, try to create an app password there, if possible. Otherwise, you can do it offline. So listen, please. Once you create this app password, then you can get into your Manage Jenkins, go to System Configuration, and you can find an email notification. So go to Manage Jenkins option. And here you have global system configuration. Click on this global system configuration. And if you can scroll down, you can find something called email notification. Like yesterday, we have configured our publish OSL plugin, right? Just above that, you can see something called email notification. And here you need to configure your Gmail server. Like it expects your SMTP, simple mail transfer protocol, that mail server details. And then if you click on this advanced settings, it'll ask for the credentials. Use SMTP authentication, your username and your access token or app token, and use SSL for security. So these are steps. So go to your Manage Jenkins system configuration and then get into your email notification plugin. There you need to enter this Gmail server. This is the SMTP URL for Gmail server. It's not like gmail.com. It is smtp.gmail.com. And the prefix here is, this is the prefix. Sorry, email suffix actually. And for this username, you can enter your email ID. Got it? So here, username, you can enter your email ID. And then the password. In the password field, you can enter this app password which you have generated. You see? So these are all the steps to be included as part of it. Clear? And another important parameter is your SMTP port number. Like from your Jenkins console, how we are going to access your Gmail server means it can be accessible through port 456. Like for example, from your VM, you are using a Tomcat server or Jenkins server, right? Using port 8080. Like that, this server can be accessible using 465. Correct. So this is about your Gmail server. Tomorrow, if you want to configure it in your enterprise level for any of your client, usually at client place will be using Microsoft Outlook as an email server, right? So it will be running on their own intranet. So they'll be providing you the domain name of that Outlook server along the port number that you can configure it here. You see, for Gmail, this is the SMTP URL and port. So tomorrow, once you complete your process, like app password is created, get into this page and enter the user name as your email ID and a password is your access token or app password. Once this is done, if you want, you can able to specify the email ID here to reply to address for testing purpose, and you can test the configuration by sending a test email. Just enter the email ID. It's like Jenkins will verify your configuration and send you a test email. Got it? Like this is what I'm entering here. And this is my reply to address and the test one. So if I entered all these parameters properly, like my SMTP server and this username and the app token along with the SMTP port, if all these parameters are valid, and if you click on this test configuration, you can check your inbox. You must be receiving an email from Jenkins server, a test email you must be receiving. So this is just to verify your email configuration. Any question on this? Any question?
No.
All clear with this? Can I able to make it?
Yes.
Okay. So if you're all able to make it, then it's good. Well and good. Or if you have any
So I
question or
have a
if you,
doubt.
yeah.
So if there is a multiple team QA team and the build team or something like that, if each member have the own mail ID, so basically they have multiple users. How can you configure this kind of stuff there?
See, they are
Right.
just the email recipients, right?
Yes.
Their ID are just the recipient IDs. Correct. They are not the owner of that server. So
Yeah.
the configurations, whatever we are doing here, these configurations, if you hope you can see my screen, right? So these
Yeah, I can able to see.
configurations, whatever we are doing here, it is not based upon the individual email ID. At enterprise level, there'll be an enterprise level account ID, right? It is
Yeah, yeah,
just a process of configuring your mail server with Jenkins server. That's all. Got it? This will never
yeah. Okay.
send your build notifications or pipeline notification. To do the pipeline notification, there is a separate process. I'll show you how to
Okay,
do
okay,
that.
understand. Yeah, yeah.
Correct?
Yeah, understand. I just got a bit confused.
Yeah. So any other question from anyone?
In Gmail, as after going to security, there will be MFA or two-step verification like that.
Two-step verification.
Oh, that one. Okay.
Are you doing it now?
No, I was just trying.
You okay? So that's what just a two-way authentication, right? Two-way verification, authentication, both are same.
Yes, yes.
So it asks for a mobile number, enter the
Yes,
mobile
yes.
number and get the OTP verified it. And then on the same page in the search bar, you search for app password and then click on app password and generate one token. That's it. Easy. Now consider we have configured this mail server and our Jenkins can able to interact with our email server. Now you can go to your pipeline project and I told you at each and every level of your pipeline, you can able to send the notification, right? So there is something called post build action. Post build action means whenever the job step is completed, as part of that, we'll be sending some notification. Got it? Say, for example, I have a job step. This is a job step. Once this job step is completed, and if this is successful, I can take it to the next step or next stage. If it is not successful, as a post build action, I can send some email notification. So when you submit any job for execution, the status of the job, it can be successful, failure, or abort. These are three state or status of your job. Either your job will be successful state or failure state, or sometimes it might get aborted. Got it? So for all these three scenarios, as a post build action, you can able to implement this. So how I can able to do this means, like I'll give you one small example here. Okay, so let me use this example for you. So I'll take the same scenario here. This is your project, right? Okay, where is the pipeline script? Huh. Okay, let's take this scenario itself. This is a very first stage. If this stage is successfully completed, what I can do, I can directly execute a stage 2. What if the stage is failed? So what I can do means I can use a post build action there. Got it? So as part of this post build action, you can see I'm just adding this block. So this is a step which gets executed. Assume that this step is going to execute this SCM checkout. And once SCM checkout is completed, if the status of the SCM checkout is fail, then we are going to invoke this email plugin, the email plugin that is installed in Jenkins. That's what we are configured now, email notification, right? The server configuration. So using that plugin, we can able to send the email notification. We can able to enter the body of that email, the CC address, BCC, from address, reply to, subject, to address. All these parameters we can able to code it as part of your email notification. And this email notification, we are sending it as part of your failure state. And it should be part of your post build action here. So this is how the syntax or block of stream. This particular block, post build activity, it is part of this particular stage. If you can see the block here, I'm just highlighting. This is a stage that starts here and ends here. And this is a step within that stage. This is a build step. Once the build step is completed, as a post build action, I'm defining this. Similarly, if your job is successful, you can able to send the success note. For example, if I use the same syntax for the deployment, what I can do as a post build action, if it is success, I can send the email on successful. And here I can able to maintain the deployment status like this. Or if I want to send, even if it is failed, let's say I want to send the notification whether it's successful or unsuccessful in both the cases. So I can able to give both the scenarios here, like failure. Can you able to understand? The BCC address, you can able to give as per your need. So my intention is, as part of the post build action, if the job is successfully executed, I mean, if that step is successfully executed, it will send the notification, this message. If it is failure, this message will be sent to that user through email. If you want, you can able to add your build tag, like your job number, build URL. Remember, we use some environment variable, right, on that day. So all these things you can able to add it as part of your body of the email. Like if I something say like this body of that email, if I give something here, like this, what it mean? So end user, they'll be getting their email, and in the body of the email, they can see the job status along with the URL. So from their inbox, if they click on that URL, it will automatically take them to the console output of the job. Understood? You can able to visualize, right, what we are trying here. Yes, no, or not?
Yes.
Yes, sir.
Let's show
Yes.
it.
Okay, so now I'll show you how to create this syntax. That is very much important. So if you can see our server, we have configured our mail server through this email notification plugin. Our Jenkins can able to communicate with Gmail server with these parameters. Now go to your pipeline project under the configuration, or here you can find something called what do you call this, pipeline syntax. If you go to the pipeline syntax, it will take you to the snippet generator. And with that snippet generator, you should able to create or configure your status of your email notification details. Yeah, it's loading, right? Let it be. Yeah. So in this pipeline syntax page, you can see there is a sample step. If you use this drop down, you can find something called mail plugin is there, right? Click on this. Now it will expect your to address, CC address and all, like something like this. CC if you want to give BCC address, subject line. Subject you can able to say anything as what I given here, deployment successful. And as part of your job status, I can able to give the body of the email. Yeah. So like this, we can able to give all the parameters. So you asked right how to send it to more than one developers or more than one team means you can able to share this to address like this. So you can able to give the recipient's email address here, or it can be a DL also, distribution list group ID also you can enter here. Understood? So with these parameters, if you click on generate, you can see this script is ready. So this is what I have coded here, nothing else. Can you see this? Any question?
No, looks fine.
So it's very easy to set up your email server and create your pipeline stage. But we have to be very clear about sending notifications. For each and every stage, you need to configure your email. Let's say if your SCM checkout is failure, then only you can send the email. If it is successful, it won't send any email, directly execute the second stage. Here, if it is failure, then you can send the email again. Otherwise, you can move on to the next stage. Like this, we can able to send the notification wherever required. Don't dump your email notifications in each and every stage. That is not at all required. No one will read all those things. It will unnecessarily dump their target email inbox actually. Stood. Any question you guys have now? Please let me know. Can you all able to make this?
Yeah, looks.
All right. So I've just given the steps in detail. You can follow those instructions and the same pipeline itself, you can take this as a template. Like if you want, you can use these things there itself directly. This is the Maven. So for in this case also, you can use your post build action if it is failure. Right after this step definition, you can give post build action, and here you can say build failed. Okay. And job status, you can use your environment variable, but ensure that you enclose it within curly brackets prefix with dollar, and it should be in double quotes. Don't use single quotes, it will not work. Easy. That's all about your email notification server. And another interesting factor here is like when we work on Jenkins, I showed you the Jenkins target server, right? I mean, directory where you can see your configurations and all. So there is one thing from admin side, we have to take a regular backup of your Jenkins server, because consider I have only one master node, Jenkins master node, And in this master node, I have created a number of jobs like this. And each and every job has its own configurations, and it will be having its own workspace, everything. So it is always recommended to take a regular backup of your Jenkins directory. So the directory means this one. Just go to this directory and copy all the folders and whatever you have and create a snapshot of it. So at enterprise level, there is a storage administrator. Usually they will be taking care of the volume level snapshots and all. Whenever they provision any server, they'll be managing it. Got it? So it is our responsibility to share the exact directory which you want to backup. And it happens, okay, every day evening we'll be taking a backup of it, it'll be preserving it, and it will be stored in a separate storage server. Whenever there is any situation occurs, like your server got crashed, or if it is unreachable, or there might be a lot of scenarios. And especially, when we try to upgrade our Jenkins server, we'll be taking a backup of it first. We'll first take a backup and then we'll upgrade it. Like this, we can able to manage your backup and recovery. And you know how to copy the directory, right, in Jenkins? I mean, in Linux machine, you know how to copy the folder from one directory to another directory.
Yeah, yeah, yes.
Same process is implemented. All right. Any question? Please let me know now. Update it here. Possible, right? This you can try from your end first, and then you can update in your pipeline script. All good? Or any other question you have, please. So with this, we are completing a Jenkins module, okay, as per your course curriculum. Shall I proceed further?
Yeah, looks sir.
So what next? Shall we proceed with the Docker module or any other module you're interested to? We have Docker, Kubernetes, Ansible, Terraform, and Prometheus. 5 more modules. Oh, then we'll be starting our interesting journey with Azure. That will be more interesting if you are interactive. Otherwise, it will be one of the boring sessions to me, actually. Okay, no, I'm not about you, talking about you, but for me, it will be very boring. So it depends upon you people.
Loksai, will we be using same tools in Azure as well? Like this Docker, Ansible, Kubernetes.
Yes, we'll use the same.
Okay, but the cloud environment will be of Azure.
Yeah.
All right, cool.
So we'll be working on the dedicated, cloud services. It's all managed services. Remember, in my day one itself, I told you there are open source DevOps tools and DevOps services from service providers like Azure DevOps services, AWS DevOps services, right? So what all things we are discussing so far, like Jenkins, Docker, Kubernetes, all these things are open source DevOps tools. Similarly, there are some managed services that we'll be learning in the Azure module. As well as you guys have AWS and GCP, right?
Yeah, correct.
The list, yeah. I'll be showing you how it is different in each and every services. As of now, you have created your AWS account. Similarly, you'll be creating your Azure account and Google account in the future.
All right. Hmm.
Fine. So let's move on to this Docker module. Where it is, where it is, where it is, where it is. Yeah, this one, right? So this is also another important module if your applications are microservice-based application architecture. So in this module, first you need to understand what is containerization, what is the difference between virtual machines and containers, and we'll be learning about the Docker architecture. We'll see what is Docker Hub and how to install Docker. And upon installation, we'll see how to work with Docker commands and execute some Docker CLI commands to work with your container images. We'll see how to create container images and how to run it and how to manage your container volumes and how to run multiple containers as service and orchestration tool. Everything we'll be seeing here. So let's get into this. Doc. So containerization, the term containerization itself, it's a very interesting term. Any guess about this terminology? Containerize means what it means? Any guess?
In layman's language, I would say to keep something in a container or to preserve it, something like that.
Okay. Okay, fine. Almost. So containerization means it is a process, actually. It is a process of packaging the application along with its dependencies. To talk about any layman perspective on Docker perspective or your development or deployment perspective, we refer to this. Containerization means it is a process of packaging your application along with its dependencies. Easy? Hope you understand the term, right? I'll show you in detail how to containerize, in which situation will be containerizing and all. Hope I'm audible to all.
Yeah.
So here we have something called virtual machines. Have you heard about it? Hmm?
Yeah, yes.
So before we actually work on this containerization, you need to understand basic difference between the virtual machines and the containers. Because I'm going to containerize. Containerize means ultimately it is going to exist as a container. So before I containerize my application, I need to understand what is a container, why I should containerize. If I already have a virtual machine, then why I need a container? I hope you all aware of virtual machine, right? What is a VM basically? You guys are expert in creating a virtual machines in AWS now.
Yes.
Yes. So what is a VM?
Virtual machines.
Within a local machine, in a local machine, within a local machine, you are creating another small machine for splitting up the by splitting up the resources. You are creating another kind of laptop. You would say small machine, server or laptop or anything.
Okay. Okay. What is a VM? in short, you can say virtual machines, right? That answers everything. Okay. Hmm?
It's an
Yep.
VM.
computing environment.
Next one says nothing but
System.
physical machine.
Hello. That is the
Like
host of
it acts like
computer.
a host.
Yeah.
Okay.
You're dissecting your hardware basically in virtual machine.
Mm-hmm.
Yeah.
Okay. Maybe it will be a kind of introduction to your cloud module also. This usually we'll talk during the next module, I mean next in Azure. But before that, I'll give you a quick introduction here. In our AWS cloud platform, we are able to create some VMs, right? Hmm? So these are all the virtual machines we have created in our AWS cloud platform, right? Assume that this is my laptop. This is my laptop. I have Windows OS in my laptop here. So any computing device will be having its underlying hardware, correct? It can be your CPU, RAM, and in my machine, I have two CPU, Core 2 Duo CPU, and I have 16 GB of RAM. Correct? In my machine. And on top of this hardware will be
So Loksai, I lost your voice. Hello?
guys, am I audible?
Now you are audible.
Yes.
Now you
Looks
are
like
audible.
looks like there is some interruption. Zoom got disconnected. Not sure.
Yeah.
Again, it started.
Correct.
Have you started or it started automatically for you people?
Automatically.
Right. That's what happened. Okay, no problem. So what I'm saying here is we are talking about the virtual machine and containers. Let me share my screen again. And you'll be getting two recordings, okay? Your previous session and this session. I mean, before this interruption, right? You'll be getting one
Yeah.
recording, and this will be another recording. Two videos will be uploaded. Okay, don't worry about that.
Okay.
Or they'll be merging it and uploading it together. It's not an issue, but you'll be getting the complete picture. So now the point here is, again, I need to draw it 1 minute. Let me draft it. So consider we are using our local machine. It's our Windows machine, which contains your underlying hardware. And this is running on my Windows operating system, correct? And I have my own CPU as well as the RAM configuration, like 2 and 16 GB. Now, in this Windows machine, I can able to run some Windows applications, right? Can I able to run any Linux or Mac or Android kind of applications?
No.
By default, it's not possible because this machine is configured and partitioned with one operating system, which can run the OS related applications. Consider I want to execute some Linux based applications. I need to demonstrate. Consider I have another batch After this, I need to demonstrate the core administration. I need a Linux machine. So directly I can't use it here. So what I can do, if I want to execute any other operating system on this machine, what I can do means on top of this OS, I can able to install one component called hypervisor. Correct. Hypervisor, it is a software component. It's like a middleware product. It gets installed on top of your underlying OS. And what is the purpose of hypervisor means? It is used to create some virtual machines. Like I can able to create a VM here, VM3. So I can able to create 3 different VMs. Each VM can have its own operating system. Let's say VM1 can run using Ubuntu machine. VM2 can run in your RHEL Linux. And this can be my Mac OS. Like this, whenever we create any virtual machine, we can able to choose the operating system as a base. And on top of it, I can able to run the applications related to the operating system. So here I can able to run some Linux applications. Here it can be my Mac applications. Correct? So point here is hypervisor. It is used to create the virtual machines. And using virtual machines, you can able to create different types of operating system in the same computing device. Easy? Understood, right? What is the purpose of hypervisor here?
And these
And
all,
yes,
and looks like all these virtual machines will be using the this own memory. The
Yes, that's what the point. So the VMs, whatever we create. So how many OS we have now?
we
How
have
many?
four OS.
For
So including the base OS, we have 4 operating systems. So all these 4 operating systems are going to utilize the underlying hardware. It is going to share. Like I have 16 GB RAM means it will be equally distributed to this operating systems. That is what the role of hypervisor. Correct. So the underlying hardware will be shared with the operating system, and you can able to run all these 4 operating systems simultaneously. Easy? Now, consider a scenario. These 3 VMs are not sufficient. I need to add few more VMs. Like I need around uh, 20 VMs now. Correct. So if I create these many VMs in the same computing device, can we able to run all these VMs simultaneously? It is possible only if you have the hardware capability. With this 16 GB RAM and 2 CPU, can you able to run this 23 VMs? Each and every VM is going to have its own OS. OS itself consumes a lot of space, right? Is it possible? Definitely it's not possible. It consumes a lot of resource and definitely your applications will not be executed. So in order to configure such things, right, first we have to strengthen our underlying hardware, right? We have to increase the CPU and the RAM configuration to accommodate the virtual machines. So this is what you can consider in real-time environment. We can consider like an on-prem server. Assume that this hardware, whatever I'm using here, the computing device, I can consider this as a on-prem server. So while we are working in an on-prem server, on-premises actually, okay, in our on-premises server, it is completely the owner's responsibility to take care of the underlying hardware requirement. Before he even create the virtual machine, he has to make some upfront investment to create the resources, right? If I'm not interested to make that investment, what I can do? I need 20 VMs, but I'm not interested to use my on-premises server to increase the CPU or RAM. So what I can do?
containers, we can use.
We
We
can
can
use
go with the
container.
cloud services, not containers. Cloud services, I'm saying.
Okay.
That is the reason we're going for cloud, right? I'm not interested to make any upfront investment. Okay, so I can quickly create an account in AWS or Azure, and with that account, I can able to create any number of VMs, right? So cloud platform is a very cost-effective one. As per your requirement, you can able to create any number of VMs, and the cost for that VM is based upon the usage, how much you are utilizing it. For that only you're going to pay. So you don't need to make any upfront investments there. Got it? So like this, we can able to. Cloud is also not a big deal. Okay, if you are creating any VM in a cloud platform, I told you there are some regions, AWS regions, and in each and every region, they can say some data center. It will be having some number of servers. As like how I showed my computing device, in one particular data center, they have a server, but that will be a high-end server with a huge configuration. Whenever you create a request for virtual machine, on their server, they'll be providing you one small portion for you. That's all. A small portion will be allocated for you. That is what a VM for them. And there also will be using an hypervisor kind of product that will create a VM. As the hardware level virtualization. Because on end user perspective, if you are using this, what we usually think like will be we have a dedicated VM or dedicated computing device for us. But it's not like that. It is actually sharing the resource. The 16 GB RAM is it is being shared with multiple VMs here. So that is what your VM here, virtual machine means. VMs are hardware level virtualization. Guys, please pay attention. And VMs are created using hypervisor. Got it? VMs are created using hypervisor, and VMs are used to execute operating system. Basically, it is used to run the OS. Once you have the OS, then only you can able to run the applications. For example, when you create a VM, you are choosing an AMI parameter, right? What is it AMI? It is used to identify your server template, which OS you want to use, whether it's Ubuntu or Amazon Linux or Mac, right? So based upon that operating system only, you can able to spin up a VM. And once the VM is ready, then only you can able to run the applications. Like these applications, what you're running based upon the OS only. Let's say we have executed Jenkins application, Java applications. All those things are running on top of this operating system. You see? And another important thing is VMs will continue to run even if there is no task application or active application or task. For example, consider I have just started this machine. This VM is up and running now. Am I running any applications there?
No.
Currently, Jenkins servers running, right? So even if there is no service up and running, the VM will be available for you. Till you stop, the VM will be up and running, correct? So it means VMs are not basically used to run the application. It is used to run the OS first of all. So it has to run a OS means definitely VM is going to consume more space and time to start up. Correct. Correct. So this is what the point. So VMs will consume more space and time to start. Let's say I have a VM. I've already installed Jenkins. If I want to start the Jenkins, I cannot directly start it. First, I need to start the VM, and then only Jenkins can be started. That's what it takes some time to start, because it has to boot your system, right? We have a OS, underlying OS is there, so it has to be spinned up, and then your application will be up and running. Easy. So these are the basic properties of a VM. Please be clear with this. It's all very important uh, on interview perspective, as well as while working in containers. Any question? Now, on the other hand, we have something called containers. So what is the main drawback in VM? If you consider this,
Each VM has to have
the main drawback here
full
is
OS.
it takes some time and space to start application. Consider I just want to start one small application or task. Even to start a small application, I need to start the VM, which consumes more time and space. And VMs are not comes with free package. You have to pay for it. Correct. Let's say you want to run your Jenkins. Jenkins is an open source tool, but to run the Jenkins, you have to pay for the VM. Correct? Yes or no? Like this, there are some drawbacks in the VM, but you cannot eliminate VM. VMs are mandatory. So how we can able to reduce these complexities or drawbacks means by using the containers. So if you want, I can take the same architecture. Consider I have my underlying hardware and I have my operating system, and on top of it, I can have my middleware product. So this is the hardware component. And now if I want to create any containers in my machine, I'll be installing a container engine. Container engine. So this container engines are used to create the containers like container 1, 2, and 3. So the purpose of containers are used to run some applications based upon the container type. Let's say if I create the container based upon the Linux means I can able to run some applications, Linux based applications there. And another important factor here is containers are not basically used to run the OS. It is used to run the task or an application. Only the hardware will utilize the underlying VMs will utilize the underlying hardware's property, but the containers will utilize the underlying OS property. So if you want to compare with VM, you can able to have all these pointers. So here containers are software, or I can say like OS level virtualization. And containers are created using the container engine. And it is used to run application or task, not operating system. So please keep this point in mind, okay? VMs are used to basically run the OS, but the containers are basically used to run the application or task. So if there is no active task or application, containers will immediately go to exit state. It will immediately get terminated or go to exit state if there is no task. It means as like a VM, let's say I have a VM here. Even if there is no task application, I can able to run the VM, but container is not like that. If there is no active task application, container will immediately go to exit state. Correct. And containers will, I mean, this is what I mentioned here. And since it is meant only for application, container will consume less space and time to start your application. You can able to quickly start your service. Let's say I have around 1,000 microservices to be started. If I'm relying on VM, I cannot start it immediately. So I can able to run everything as a container. So basically, containers are used to deploy any microservice based application services. You see, each and every service in your microservice based application architecture will be executed in its own container. Understood? And there is another interesting factor in container. Containers run in its own isolated address space. That means, consider in this scenario, I've created 3 containers. In container 1, I'm running an application. So what are all the applications you are running inside the container? The scope of the application is within the container. Even the neighboring container or even the underlying OS will not have any clue about what you are running inside the container. It is completely isolated one. Correct. So it creates a complete, it's like individual process. Independent process will be created for each and every container. And how it is possible means by using the underlying properties of operating system. Like your namespace, and we have something called control group. So namespace and control groups are the 2 important properties of the operating system, which helps to create an independent process and allocate independent resources to run the process. It is the property of the OS. Let's say in your machine itself, there is something called process, right? Like you can see there are a lot of processes up and running here. And each and every process has its own CPU and memory. It is having its own disk space and volume network, everything. It will be having its own process ID internally, correct? So like this, we can able to manage all these parameters with the help of these 2 components, namespace and control group. It is applicable part of any OS. So through these 2 components, containers can able to run in its own dedicated isolated address space. And once a process completes, automatically the container will go to exit state. Easy? So this is the basic difference between your virtual machines and containers. Any question?
For this, every time we need to create new container.
Yeah. Once the process completes, the container go to exit state. You can create another container to start whenever required. We never keep, there is no purpose of running the containers permanently, right? Whenever you need to exit any task, start it, otherwise you can exit it. That's all. Easy? All right. So now let's get into the next important thing, how we can able to work on this. So comparing these two entities, right, which one is more advantageous?
Like it depends.
Depends upon the requirement.
Perfect. We never say container is completely and no advantages one. It is purely depends upon the use case and scenario. So using containers, we can able to reduce the number of VMs, but you cannot completely eliminate the VMs. VMs are the base. Let's say if you want to, I'll give you one architecture here. Listen carefully. Consider I have created a virtual machine in my AWS cloud platform with the underlying T2 medium and the operating system. Got it. And now I want to create or execute 100 different types of applications. Okay. So if I want to do that, I'll be using this architecture, and consider I have a hypervisor installed. So with this hypervisor, I can able to create one VM like this, and assume that I have installed Linux OS here, Linux Ubuntu, and here I have Linux CentOS kind of OS. Now on top of this, I can install container engine, and I can able to have container engine here. And using container engine, I can able to create a number of containers, right? Possible. So all these things are containers actually. So like this, we can able to use both the virtual machines and the containers together in such complex architecture. It's possible. Okay, we'll be implementing in some real-time environments, especially while spinning up some huge list of test servers. We'll be needing this architecture. Now, the point is, if you want to work in this container or containerization, first of all, you need to understand some terminologies. Okay. And then the architecture. And then you should know how to install and work on the components. So there are various terminologies involved here. If you want, you can have a quick 5 minutes break and come back. We'll talk about that. Okay, because it's a bit lengthy, and for some of you people, it might be boring. So better you have a quick refreshment, come back. We'll talk that in detail. Go ahead, please. I'm here. If you have anything else, let me know. Okay, so shall we?
Alexa.
All right. So there are some terminologies we need to understand here before we actually get into the architecture and other things. Hope you all back. Let's continue. Yeah. So the first thing what we have seen here is the container. Containerization. So what is it about containerization? It is just a process of packaging an application along with the dependencies, right? And when we say package in containerization environment, we call it as an image, correct? So image means it's a static file. Image is just a static file that defines the properties and dependencies of application to create a container. And another important thing is images are non-executable. Right. Images are non-executable. It is just a static file which can be created and which can define the properties and the dependencies of the application. And another important point here is images composed of various layers. Okay. Of instructions. So how these dependencies are created or defined means by using the instructions that you code. It's like a script which we create. And as I said, images are non-executable. Then how we can execute image means by using the containers. So container means is an executable unit of container image. Correct. So it is not just an image, it's a container image, I can say. Correct. So any container image is a static file and it is non-executable. If you want to execute that, you have to create a container out of it. So these are the executable unit of your images. Easy. And another important thing here is there is something called container registry. So this container registry means it is used to version control. Or version control the container images. Let's say I have created one container image. I've just created a file that defines a property of the container. I've just created that container image and I want to save it. So where I can save it means I can able to save it in a container registry. So it is something like application developer create a source code and they will save the source code in a source code repository, right? Like GitHub repository. Similarly, the container images can be saved or managed in your container registry. And here we are going to use Docker Hub as a container registry. Correct. So we'll be using Docker Hub. So in order to work on this, first we need to create Docker Hub account. I'm not sure how many of you created it, but anyways, I'll show you how to do that. Easy. And another important term here is container. What is it called? Repository. So when we say container repository, it is a subset of container registry. All right. So container repository is a subset of a container registry. So when you create a container, you will be actually storing it in the container repository, which is part of your container registry actually. Easy. Are you able to understand the difference between container registry and container repository?
Can you repeat one more time?
So
Yeah.
container registry is used to version control the changes or your container images, means the actual thing will be maintained in container repository. Container repository is just a subset of your container registry. Say for an example, you have your GitHub server, GitHub account. In that GitHub remote server, you create one repository, correct? Within the repository only, you maintain your application components, source code. Like that, you can able to create any number of repositories in your GitHub account, right? Correct. This is repo 1. This is repo 2. Like this, we can create any number of repositories. Similarly, at enterprise level, you'll be having one Docker Hub account. This is your Docker Hub server. That is your registry. Within that, if you want to save your image, you'll be creating that repository here. So this repository is present within the container registry. That's why it is called as a subset of container registry. Easy. Am I clear with that? Yes, no.
Yes, sir.
Yes,
Yes.
understood.
Yes.
Okay, so container images, container repositories. So a lot of scenarios, okay, one by one we'll see. And another interesting factor, how we can able to create the container image, how to create a container. We use one term called container engine, remember? So what does a container engine means? It is used to create container images and containers. Okay, so to create and manage the container images and container registries. So it is a tool that get installed, and through that only you can able to create the containers, container images, and other stuff. Okay, so in order to work on this, first you need to create a Docker Hub account. So I'll ping you the URL now. Listen, please. Let me put this in chat window. So this is the URL. Please bookmark this link. Okay, I'll put this in chat window now. Can you? So if you get into that URL, you can able to create an account. There is an option to sign up, and while using the sign up option, you can able to refer the GitHub account. Already, if you have a GitHub account, means you can use the same GitHub account details to create this account. It's possible. Okay, just a matter of 1 or 2 minutes to create an account, not more than that. Can you create now, or you can create it offline?
Sir, we did not get any link in the chat box.
Okay.
You have not received the URL.
Okay, so I think I just shared it. Let me check. It's not reached you people.
No.
Okay, let me check with your admin now. Moment. Okay, I just requested for access. I think I'm unable to share these because it got disconnected now. So maybe it is not allowing me to share. In few seconds it will be available. Just wait for some time. Let it be. So anyways, that link is available in your class notes. You can utilize it. hub.docker.com. If you use this link, you can create an account quickly. Not required now, but before you join the next session, I expect every one of you to create an account. Possible? Is that possible, or like any challenges there?
We'll do it.
Yes.
Yeah, it's
All right. Fine. So how to work on this actually? What will be your roles and responsibilities while working in containerization? Okay, so architecture, all these components are part of the architecture. Correct? All these components are part of the architecture. So if you talk about the container architecture, you can able to see the container engine, your container registries, your container image, containers, and then your CLI commands. So if you are working in a Docker means you need to install Docker container engine. All right. So using Docker container engine, we can able to create some Docker containers or Docker container images. You see? So all these components are part of your container architecture. Okay. So now how to work on it? What is the actual use case? Who can able to use this means, like for example, yeah, I think now I can able to share. Let me put that in chat window for your reference. Let me know if you all can able to receive it.
Yes.
Yeah,
Okay.
we are.
Yeah. Please bookmark the page. You can do it after some time. Now you can able to work on containers on two different scenarios. In real-time environment where we are going to implement this, what are all the use cases means, like you can able to work on containerization on two perspectives. One is on the developers or deployment perspective. Another thing is on the infrastructure perspective. Okay. So these are two areas where we can able to implement containerization in real-time environment. If you are clear with these two approach, right, you can able to understand the real-time implementations actually. Okay, so it is not about creating containers and working on your container CLI commands that anyone can able to do, but understanding the purpose of it is very much important. So on infrastructure perspective, what is the role of infrastructure management team? What is the role of infrastructure management team? It is actually their responsibility to
set up the underlying
Set up
infrastructure.
the
It is their responsibility to provision the infrastructure, right? Create the servers, and they'll be responsible to install the packages, right? Softwares, everything. So now, let's say, for example, you are from DevOps team, you are a DevOps lead or architect, and for one of your clients, you have to implement DevOps by using Jenkins. So in our previous module, we talked about it, right? Like Jenkins architecture. It is based on master slave architecture, remember? I just drafted somewhere here, right? This one. So it is purely based upon the master slave architecture. Assume that this particular customer is having a huge set of application tools with a lot of build and release frequencies. And you have to create this architecture now. So to create this architecture, how many servers you need actually? In this case, how many servers you need?
6.
There are 6 VMs required to set up this architecture. If you simply take this proposal to your infra team, right? Even you are a DevOps architect, you should have proper business justification. If you are failing to justify this requirement, infra team will not approve your request, because always the infrastructure team will be concerned about the infrastructure cost. If you want to create a VM, it should be approved by them, because end of the day, the infrastructure cost is very much important there. They always try to save the cost. Honestly, they won't, give it for granted. Anyone who requests, you can't expect from them. So you need to have a proper use case and business justification to create this architecture. So here I just have around 5 different types of applications. Okay. Consider I have nearly 100 different types of applications I have to build. Can I expect 100 VMs?
No.
As part of Jenkins architecture, if I ask for 100 VMs, is that reasonable? Do you think they will approve it? But still I need, right? So what I can do on infra perspective, how I can able to manage the situation means, instead of creating the VMs, what I can do means I can simply use the containerization process. So I can use the same architecture, let it be Jenkins master, and I can have another VM. Let it be I can consider this as a slave node. It is also a VM. Okay. So this slave node is attached to a master node. Now, like this, I need around 100 VMs, but I'm not interested to create 100 VMs. Instead of that, what I can do means I'm going to install container engine. Usually what we do, we usually install the required build tools in that VM, correct? Like Java, Maven, and other stuff. Instead of installing the build tools directly in this VM, you install the container engine, and using container, what you can do? You can create containers, right? So you can able to create a number of containers you need, C1, like this. And each and every container can be considered for its own application build. So now I just reduce the number of VMs from 6 to just 2. Just one VM is sufficient to create a number of containers, and each and every container I can able to build my own application. So if if a request is there for Java based application build, through Jenkins pipeline, I can able to schedule to run the slave node. And once the controller reaches the slave node, it creates one container based upon my script. And in that container, it will download the source code, perform the build, create the artifacts. Once artifact is ready, it can be promoted. And then this container will be deleted permanently. That's what, because As per the property of a container, if there is no active task or if the task is completed, the container will immediately go to exit state. So this container 1 will be deleted or it will be into exit state. So what is the purpose? Why we exit the container if there is no process means it will just this resource. The space and the process, how much utilized by this container, everything will be released for other containers. So this is how we can able to effectively utilize the underlying resources. Easy. So using containers on infra perspective, we can able to save a lot of VM cost. Am I clear with this? It's all scenarios, okay? Very much important for interview discussions. During interview, they'll be getting a lot of questions like this. Am I clear with this approach?
Yes.
So going forward, don't think about creating the VMs. If you have containers in place, try to utilize the containers and make the things done. I mean, make it work using containers itself. That is what the approach, future approaches. This is one scenario. Consider there is another scenario that is on the developers or deployment perspective. So when I say developers or deployment perspective, what is their role actually? What is the role of a developer? They just create the source code, correct? Somewhere I was writing it, no? Like, what is the build? This one. All these activities they will be performing, correct? I hope you remember the environments we have.
Yeah, yeah.
These are all the environments, right? Okay, let's consider this environment. So what is the role of a developer here? Developers in their non-prod environment, that is within the dev environment, they will create the source code, correct? Once the source code is ready, they will build. That means compile the code, compile and create artifacts. Assume that I have created one artifact like my web app 1.war. This is the war file I have created here. And it can be unit tested also, because without unit testing, we cannot promote it. So they can able to perform the unit level testing. And what they can do, they can able to validate the result. And once it is done, they'll try to promote the my web app 1.war file to target environment, right? Assume that we have, let me summarize this just quickly with the QA environment. So now once the product is ready, once it is built and war file is ready, as part of the deployment, assume that is a QA environment. So this war file will be copied to the QA server, right? Through Jenkins, that's what you did, no? Correct. Now, before I actually promote my artifacts to the target server, I have to do a thorough testing. So to run this web application, what I need, I'll be using my JDK and I'll be using Tomcat, and I can able to run this war file. Based upon these two tools, I can able to run this web application and it will be successfully executed for sure. No worries on that. Once it is successful, then only I can able to promote it to target environment. Now, once the product reaches the target environment, the QA testing team should run the same artifacts, right? To do the QA testing. So to run what they need, to run that, what you need?
The artifacts.
Artifacts already deployed. No, that's what upon deployment I'm saying. To run this web application, we need a web application server, right? We need a Tomcat and JDK, correct? Simply, I cannot run this, right? I need this Tomcat. Remember, that's what we did in a Jenkins model, right? In QA server, what you installed? Tomcat, no? Are you following or not? Guys, is that
Yeah, yeah, yeah,
Yes.
understandable or
Yeah,
confusion?
yeah.
yeah, yeah.
So this artifact has to be executed in the QA server, and then only you can able to test it. But sometimes what happens, the application that is running successfully in their lower environment might not be successful in the higher environment. It is not because of the application logic. It might be because of the environment or infrastructure. Let's say developer in lower environment, they have used JDK 17 version and Tomcat 8.5 version. With this JDK 17 and Tomcat 8, they can able to run this application. But in QA environment, assume that they just have JDK 11 and Tomcat 8. Can you able to run this here with this version?
No.
May or may not be. There might be some compatibility issue, right? The application might not be compatible to run with JDK 11 because it's a very lower version. And also this Tomcat 8 is not equal to Tomcat 8.5. So it might not work. So all these situations happens in your target environment. Same thing is applicable to QA environment, even the production environment. Correct. So how the situations was handled initially means, initially we were using our monolith application architecture. Monolith means for the entire application, there'll be only one artifacts that will be developed. Before you promote the code to QA environment, you will reach out to your infra team. They will keep that environment ready for you. They will install JDK 17 and keep that environment ready for you. Similarly, all the higher environments will be upfront ready before you perform the deployment. Because it is just a monolith application. One application I'm going to deploy for that just one tool or one service is more sufficient. But in microservices application architecture, we are going to create thousands of microservices. Each and every microservice has its own source code repository. Each and every application has its own source code repository. And based upon that, we'll be creating thousands of artifacts, right? When you perform build on the source code, you'll create one artifact. Like this, you'll be creating thousands of artifacts. And each and every artifacts can be of different versions of tool. Like artifact 1 can be using JDK 17, another can be JDK 11, another can be JDK 8, or sometimes we'll be using Oracle JDK. Like this, each and every microservice has its own tool and versions. Can we expect all the versions of JDK in QA environment? Possible. Can we install all the versions of Tomcat in the QA server? Practically, it's not possible. So what we do means, instead of directly deploying your artifacts to target environment, we use a concept called containerization. So what is containerization? I told you, it is a process of packaging your application, right? So developers, once the changes are ready, once they create the artifacts, and once they have performed the unit level testing, if they're ready to promote the code, they will just package this application along with the dependencies. So I can say like a package. Let it be like my web app 1 image 1. So this is a image. It is in a Docker perspective, this package is also called as a container image. So containerization means that's what it is, a process of packaging your application along with dependencies. So now what this package is going to hold means, it is going to hold the application artifacts .war file along with the JDK 17 and Tomcat 8.5. Easy. So once the war file is ready, upon testing, developers will create this container image using Docker. Now this image composed of the application along with the dependency. That's what containerization means. Is that clear? Hope you can understand what is containerization now. Thank you. Now, once the image is created, we have to save the container image. That is my web app image one in the Docker Hub container registry. That is what the purpose of a container registry here. It is used to save or version control the container image. What are all the images we have created here? You cannot directly copy that image to target server. You cannot directly deploy to target server. It should be first save it into the container registry, and from there only it can be downloaded to the target server. As like how we use a git clone to clone your repository to your local machine. Similarly, in any target server, if you want to download that image or deploy the image, that can be done through your container registry only. So now this image can be deployed to your target server. And in target server, even if you don't have a JDK or Tomcat, that doesn't matter. All that you need here is you need a container engine. In all the target server, we just install container engine. Once you install container engine, using this container image, you can able to create the container and run that application as a container application. Understood? As like how you are creating a container in this architecture using container engine, in this target server also, you can have your container engine and you can able to create an application container using the image which you just deployed. Easy. Any question? Guys, are you able to understand the scenarios here? Like what are all scenarios we can able to use containers? Containers can be used in infra as well as in your deployment or development perspective. So most of the cases will be using this in the development perspective. So in the upcoming sessions, we are going to learn about all these things, like how to use your containers, how to create a container. So if you want, I can just start with the installation process. So the next session, we'll see how to install container engine. And then also you need have Docker Hub access. I'll show you how to work with Docker Hub, how to manage your images in Docker Hub, everything. And then we'll discuss about the Docker CLI commands. So using this Docker CLI commands only, we can able to create an image. We can able to create a container, all those stuff. Any question? Let me know, please.
When we will move to UAT, the same thing we will copy, just like QA.
Yes. Any container, any target environment, we need a container engine. So using the container engine, you can download that image from your container registry to that machine and then create a container out of it.
While we were using Jenkins, there we are not using this concept. We are using the same process like deployment to, but when we will using Docker, then we will use this concept,
Yes, that's
containerization.
right. That's right. So once you complete Docker module, I'll show you how to integrate this with your Jenkins.
Okay.
So using Jenkins, we can create a container image based upon the artifacts, whatever we created there. See? All good?
Yeah, hi, Rockstar. So developers are the responsible to create the Docker image.
Yes, it's their responsibility completely because they are the application owners, right? They know what is the name of the artifacts they want to create, and to execute the artifacts, what are the dependencies they need, whether it is JDK 11 or 7, it depends, right? So they are responsible to create it and deploy it. We are just going to automate once it is done.
Okay, fine, thank you.
So after this container image we have deployed in the QA server, so that time that container engine will be deleted.
No need to delete, right? Why to delete it? What is the need?
No, no, just we have told just like that after that container engine will remove that
Container
part.
engine will not get deleted. Containers will be deleted, I told you, right? It is not about container engine. Container engine is a software through which you can create the containers. Once the container execution is completed, that container will go to exit state. That's what I mean, not container engine.
Okay, so the task will be removed. There.
Yes.
Sir, can you explain me that namespace and control group? I can't able to understand what is really are.
See, it is a basic property of any operating system. Let's say I showed one example here, right? The task manager. Any task
Yeah,
or
yeah.
any process you run in your machine, that process or the task will be assigned with a unique process ID. It will be having its own network, inter-process communication, all those things, right?
Okay.
So here you also can see this particular application is consuming around 40 or 27.4 MB. So how this volume is allocated? It is allocating some dedicated volume for this. It is allocating some dedicated process for that, right? So it is possible through that component of your namespace and control group. So you know the term kernel, right? Kernel is a core of the operating system, right? So
In
namespace,
Linux also you just mentioned these two things, but I can't able to understand.
yeah. So it is a core of the operating system, which is going to manage all of the resources. Correct?
Okay, okay,
So
understood.
through that, the container can able to run in its own isolated address space, isolated path, you can say. All right.
Yeah, okay, sir.
Okay. Yes, guys. So any other question from anyone? All right. So please revisit this document because you have 3 more days in between Saturday, Sunday, and Monday. So before you join Monday session, I'm expecting every one of you to go through the content. There is no lab or demo something here. Just go through the contents like the understanding what is containerization, especially the terminologies. So from Monday onwards, it'll be like a completely a demo session on Docker module. We'll be focusing on this Docker CLI commands. And once I complete this Docker and Kubernetes, I'll show you how to integrate and automate this process of containerization using Jenkins. It is not part of your curriculum, but still I will uh, enhance your existing pipeline and I'll show you how to create your end-to-end pipeline as per the real-time scenarios. Easy?
Okay, sure, looks.
Yes,
All
sir.
right. All right. Any other question you can ask me now? Yeah, I opened the poll.
Yeah, it's done.
All right. Thank you. All good. Hope things are getting progressive, right? Every day we are learning new things. Please practice, okay? If you postpone the things, it's very difficult to manage at the end. So whenever you find time, or even if you're unable to allocate, please try to accommodate, okay? Try to manage, give some priority and start practicing. All right. Thank you. If you don't have any other question, we'll close this call. We'll connect on Monday. Thank you all.
Yes, thank you.
Thank you so much.